Dear students, in this video, I am going to solve one question from polynomial. Here we have a questions from the polynomial, two questions from the polynomial. And the first questions, we have to solve the given cubic equations and then find the roots of x. And in the second equations, we have to factorize the given cubic equations. And we remember that the solution of factorizations, it means the solution of that second questions is the part of solution of that first questions. It means the equations. So once we solve one questions, then another questions will be solved itself. So I have taken the question number 1. It means I'm going to solve the cubic equations 2x cubed minus 3x squared minus 3x plus 2 is equals to 0. So now let's begin the solutions. In the solution of that first questions, here we have a given solutions. So the questions, the cubic equation is this. This is our cubic equations, and this cubic equations does not have any names. So what I did here, I have taken only left hand side of that cubic equations and consider as a polynomial f of x. So I have suppose f of x is equals to the given polynomial 2x cubed minus 3x squared minus 3x plus 2. And then later you can see that here plus 2 is the constant term of given polynomial. So I have written here, since the constant term of polynomial is plus 2, you can write only 2, no problems. Then we can write the possible factors of that constant term. The possible factor of this 2 are plus or minus 1. Plus 1 can divide 2 without any remainder. It means keeping remainder 0. And then minus 1 can divide that 2 keeping remainder 0. And then another one is that plus 2 and then minus 2. Both of them are the factors of the given constant term plus 2. So while solving these types of questions, first we should write the constant term first and then write the possible factor of constant term. After writing the constant terms, you know that on the set of constant terms, there will be at least one factor which will satisfy the given polynomial. It means among plus 1, minus 1, plus 2 and then minus 2, at least one value will be there which will be satisfied on the given polynomial f of x. So I'm going to find such types of value by which the value of f of x becomes 0. So let's see. Here I have taken x is equals to plus 1 and then I found f of 1. You know that if you have given f of x is equals to 2x cubed minus 3x squared minus 3x plus 2, and while finding f of 1 we should simply replace x by 1. Here I have replaced x by 1 and then found the values of f of 1 is equals to minus 2, which does not equals to 0. We need that factor which makes function f of x is equals to 0. It means that polynomial is equals to 0. Now here I have taken the another values of x, that is x is equals to minus 1. And if I substitute x by minus 1, then I found here 2 into minus 1 to the power 3 and then 3 into minus 1 to the power 2 minus 3 into minus 1 plus 2 is equals to, I found 0. When I substitute x equals to minus 1 and the given polynomial, then its answer is equals to 0. I found the answer 0. Now, do you know by the factor theorem, if f of a is equals to 0, then what we can say here, x minus a is factor of f of x. This is given by the factor theorem. Similarly, here if you got f of minus 1 is equals to 0, then you know that x plus 1 is factor of f of x. So now I am going to write the same thing on the solution of these questions. You can see that here we got f of minus 1 equals 0. So by factor theorem we can claim that x plus 1 is the factor of f of x. So dear students, my dear students, I have found on the most of the solutions you haven't written that this part of the solutions, even some of the students left to write that factor theorem here. So you must have to write, you must have to show this part of solutions, as well as you have to write the by-factor theorem. So without factor theorem, we can't claim that if f of minus 1 equals 0, x plus 1 is the factor of f of x. So it is given by the factor theorem. It is, that told by the factor theorem. Because of that, we have to write here factor theorem. So this part is also a part of solutions of this question. So don't forget to write that by factor theorem and then this part of solutions. So let's go ahead. Now we are going to divide f of x. It means that supposing polynomial f of x by the factor which we recently obtained, that is x plus 1, okay, we are going to divide f of x is that polynomial which we suppose on the beginning of the solutions, and then we are going to divide that polynomial f of x by the factor which we recently obtained, that is x plus 1, by using synthetic division method. So here I have written here by using synthetic division methods. In synthetic division methods, you know that we should write x equals to minus 1 because we are going to divide by x plus 1. So compute that x plus 1 to x minus a, then later you will get that a equals to minus 1. So we will divide by that a equals to minus 1. Also we can write x equals to minus 1, or if you don't want to write there x, no problems, you can write just minus 1 there. Now you know that how to divide one polynomial by the another polynomial by using synthetic division methods. And we remember that to use the synthetic division method to divide the polynomial, always the degree of divisors should be always 1. It means only we can divide by the linear polynomial by using synthetic division method. So now here I have written the coefficient of x cube. You can see that here the coefficient of x cube is 2, coefficient of x squared is minus 3, coefficient of x is that minus 3, and then constant term is plus 2. So I am going to write the same thing here. You can see that coefficient of x cube is 2, coefficient of x squared is minus 3, coefficient of x is minus 3, and constant term is 2. Now we know that how to divide in synthetic division methods. So now write this 2 as it is just below the line, that is 2 as it is, and multiply this 2 to this minus 1, and write the product of that 2 and that minus 1 on this place. That means 2 ones are minus 2. So I have written here minus 2 as it is, and then the sum of minus 3 and minus 2 is equals to minus 5. You should write here minus 5. Again multiply this minus 5 to minus 1, and then write its product here, and then minus 5 into minus 1 this is equals to that 5 minus 3 is equals to that is equals to 2. It means here we have to find sum of plus 5 and then minus 3. It will be plus 2, and again if you multiply that 2 and then that minus 1, and the product should be minus 2, and the differences between 2 and minus 2 is equals to 0, which is our remainder. Now by the division algorithm, dividend is always equals to, yes, divisor, divisor, divisor multiply by quotie and the quotient and sum to the remainder. So I have used the division algorithms where our dividend is that f of x and divisor is our x plus 1, and quotient just we obtain here and the remainder just we obtain here. You can see that. So here I have written where quotient is equals to, that quotient is equals to 2x square and then minus 5x and then plus 2. So I have written here 2x square minus 5x plus 2, and the remainder we found here 0. So I have written here remainder r is equals to 0. Now when we substitute qx mean quotient be by that 2x square minus 5x plus 2 and remainder by that 0, then the polynomial f of x becomes x plus 1 multiplied by 2x square minus 5x plus 2 plus 0, and that 0 doesn't have any meaning here. And now so what I did here, I have just break its middle term of that minus 5x is minus 4 and minus 1. That just we have to split the middle terms and factorize it, and then I have break that 5x is minus 4x and minus x, and then I have taken the 2x common from the first two terms and then minus 1 from the last two terms, and then finally I found that x minus 2 is the common, and then 2x minus 1 are the rest terms. So we factorize f of x in the form of, in the factors, x plus 1, x minus 2 and 2x minus 1. So if you have a quotient factorize that 2x cubed minus 3x square minus 3x plus 2 only, so these quotients has the solution up to this. So the factorization or the factorize has this much solutions. So if you solve up to this, then the solution of the factorizations will be over. So this much the solution of the factorization. But do you know that in a solutions here you have given is equals to 0. So you know that we have considered at the beginning of the solutions this is equals to f of x. So can you write that f of x equals 0? Yes, we can write. So what I have written here, but we have f of x equals 0, and we have already factorized that f of x is x plus 1, x minus 2 and 2x minus 1. So I have replaced that f of x by x plus 1, x minus 2 and 2x minus 1 is equals to 0. And now we can write in either our form. So x plus 1 is equals to 0, and this implies x equals to minus 1. X minus 2 is equals to 0. This implies x equals to 2, and 2x minus 1 equals 0. That implies x equals to 1 upon 2. And then finally we obtain the values of x are minus 1, 2 and 1 by 2. These are the solutions of x. It means minus 1, 2 and 1 upon 2 are called roots. Sometimes it is called zeros of given polynomial f of x. It means given, you know, that equations 2x cubed minus 3x squared minus 3x plus 2 is equals to 0. So now here you can copy the solution by pausing the video. So you can copy it up to this, and again you can copy this. Again copy the rest of the part. Copy it. So this much in this video.